All right, we sort of talked about this particular piece of paper in our Wednesday class, and we found out that if I'm adding or subtracting functions, I can just add or subtract their derivatives, but you cannot simply, if you have a product of two functions, multiply their derivatives, nor if you're dividing two functions, can you simply divide their derivatives. Under no circumstances are you to do that. So the product rule is for when you are multiplying two functions, and the quotient rule is when you are dividing two functions, and it is not f prime times g of prime. It is not f prime divided by g of prime. Those are absolutely not allowed. Do not do it. It is not that easy. So please take note that there is a product rule, and it is in your formula packet, so don't have to memorize it. Same with the quotient rule. So the product rule is when you have two things that you're multiplying, you take the first function times the derivative of the second function plus the second function times the derivative of the first function. So you'll notice each function has a derivative, and it gets multiplied by the other function's just general function. I'm going to give you an example of that in a minute. Quotient rule is a little bit worse. It is the bottom function times the derivative of the top minus the top function times the derivative of the bottom, all divided by the bottom function squared. Oops, goodness. I don't know why I wrote a b there. Actually, I do know why I wrote a b there, because I was saying the word as the bottom function, but the bottom function is g. So again, bottom times derivative of the top minus the top times the derivative of the bottom, all over the bottom function, which is g squared. Sorry about that. So look at, you find these in your formula packet. Find them so you can believe me. Sometimes different textbooks put things slightly differently, but the important part about this is that, again, notice one derivative, one function, the other derivative, the other function. But because this is subtracting, it's very important that this one is in the front, the bottom times derivative of the top minus the top times the derivative of the bottom. Now, some people talk about this in terms of like this is the function on the bottom, so it's lower, and this function on the top, so it's higher. So the little fun saying is low d high, so low times the derivative of the high one minus high d low, the high function, times the derivative of the low function, all over low squared. So like a little song, low d high minus high d low, all over low squared. But these are the product and the quotient rules. Get to know them. You will need them. But keeping in mind that this g prime here, this f prime, are just the regular derivative rules we already know for whatever function this is for each of these. So I'm going to now take you, so first you should be able to answer all these challenges down here now in terms of what the slopes are. But I'm going to take you to this, which was your homework, and on the bottom of that, it asks you to pick two functions from the 20 above and multiply them together and use the product rule. Do the same thing with the quotient. So I'm going to let you do that, but I'm going to create my function. I'm just going to pick two. I'm going to make my life nice and easy. So I'm going to go 4e to the x times sine x. All right. So there's my two functions. This is my f times g. So the derivative is first times the derivative of the second plus the second times the derivative of the first. It doesn't matter what order you put these or what order you put these because you're multiplying. And it doesn't matter what order you put these actually because you're adding. But what that means for me is the first function is 4e to the x, so I just write it down. And the derivative of the second function, the derivative of sine, is cosine. Plus the second function is sine x, so I just write down sine x, times the derivative of the first function. Well, the derivative of 4e to the x, this is why I made it easy on me. The derivative of 4e to the x is 4e to the x. And that's your derivative. Now, if I'm crazy, which I am, I notice that there's a 4e to the x in the front term and the back term, so I could factor out a 4e to the x, which would leave me a cosine x plus sine x inside of parentheses. And the reason this might help me is if I want to know where the tangent line is horizontal, I would be able to set this equal to 0, and now I would be able to solve to get that answer. So I'm going to do the same thing with a quotient rule. I'll pick a different function for us, two different functions. So I will do y equals x squared plus 3x divided by, I'll just do cosine of x. Get some trigs in here. All right, so the quotient rule is if I have two functions being divided, which I do, there's f. So again, this is my f function here, and this is my g function. The derivative was the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And that's my derivative. So if I want to do that, this gets a little bit messy. There's no way around it because you got a lot more going on. So I'm going to extend my page. So that means that I have y prime is going to equal, the bottom function is cosine x, so I just write cosine x times the derivative of the top. Well, the top is just a polynomial. So I'm going to put parentheses because the derivative of this is 2x plus 3. And I need to be aware that this cosine would be multiplied by that entire function. Minus the top function is just x squared plus 3x. So again, I'm going to use parentheses because I'm subtracting this whole expression. And then the derivative of the bottom, well, the derivative of the bottom is negative sine x. And again, I'm going to use parentheses so I don't think I'm subtracting, because I'm not, because this is multiplying these two. So they're in parentheses to indicate multiplying all over the bottom squared. And if I square cosine, it's cosine squared x. And so if I want to clean this thing up, which I honestly don't really want to do, because if I distribute cosine to both of these and sine to both of these, it's not going to really be able to combine anything in particular, because cosine and sine can't be combined. They're not like terms. But what I can do is kind of write it a little consistently. Cosine of x over 2x plus 3. And this negative sign times this negative 1 would become plus sine x times x squared plus 3x. All over cosine squared. Now I just made those two functions up on the spot. So sometimes your functions that you do, you will want to distribute into each other, because then you can combine like terms. And then you can solve, because if I wanted to find when this function had horizontal tangents, when it had a max or a min, I would want to set the top equal to 0 and solve just like we did finding the zeros of the derivative on the earlier worksheet. All right, so there's your product rule and quotient rule. Practice them. It will take some practice. That's okay. All right.